Welcome to the TechArena, featuring authentic discussions between tech's leading innovators and our host, Allyson Klein. Now, let's step into the arena.
Welcome to the TechArena. My name is Allyson Klein, and I'm coming to you this week from the OCP Summit in San Jose, California. I'm so delighted to be joined by Robert Hormuth and Prabhu Jayanna from AMD. Welcome to the program, guys.
Thanks, Allyson. Thanks for having us.
Thank you, Allyson.
So why don't we just start with introductions? Robert, do you want to introduce yourself?
Sure. Robert Hormuth, Corporate Vice President of the Data Center Solutions Group Architecture and Strategy team. So we're focused on finding the yellow brick road to the future and planning the path there.
And Prabhu?
I'm Prabhu Jayanna, Senior Director, Product Security Architecture and Advanced Prototyping. I focus on developing advanced concepts and get them into products, roadmaps over time.
You know, OCP is one of my favorite events of the year. I think it's a great place to get a sense of where the large cloud service providers are aiming for their future infrastructure and what they need specifically from the silicon arena. Forrest Narad gave a talk earlier today where he talked about the EPYC architecture and how it's made incredible advancements in terms of what these large players can do. When you look at cloud native, and we'll just start with you, Robert, when you look at cloud native workloads and you look at what you've delivered with EPYC, what do you think stands out as the real differentiating capabilities of that architecture? And what are you hearing from your large customers about what they need as they move forward in this AI era?
Well, I think, we need to start a little bit with cloud native as a catch-all phrase. It's almost as glorious as cloud. But when I think about cloud native, it's more about a principle of design. It's an architecture, it's a style, it's a replatforming of applications that is really focused on having application scalability, flexibility, the resiliencies built in the application, not at the infrastructure. It's about observing the applications, the speed of delivering, updating, managing, deploying. So it's a whole bunch of things that define cloud native. And, there's a lot of workload changes that have gone over the last, 40, 50 years. When we think back to the large monolithic physical applications of yesteryear to the virtualization IaaS. Well, that's more of a delivery vehicle, but it's still a very monolithic kind of style application development and framework. But then as you start to move towards containers and microservices and functions and function as a service, the implications of the underlying hardware is very profound when you think about large monolithic multi-core threading, shared variables in the caches. All that locality is really important. And, you have maybe one per machine. You go pivot to the far contrast of function as a service, and there's thousands of these little functions. They talk to each other over TCP/IP. It's write once, run anywhere kind of, and run anywhere and when needed kind of model. And so it really drives architectural choices at the microarchitecture level because of that drastic difference in terms of density of functions, the data locality. It creates new system bottlenecks in terms of memory bandwidth and branch predictors and data locality. And you think about these functions that maybe run for milliseconds. It's hard to get your branch predictors to train when you have thousands of them running and they only run for short segments of time. And so that's what, at AMD with the Zen 4 microarchitecture, we were able to take, one base microarchitecture and then optimize for that whole spectrum. And if you look at the suite of the Zen 4 launches from Genoa, large, big core, high frequency, big cache, Genoa X, even bigger cache, to the new Bergamo, high core density, we tailored it more towards that cloud native with smaller caches,
right,
and more cores and more defined, guaranteed memory bandwidth and all of that. And so we were able to take one microarchitecture with a common ISA, which is really key, having one ISA, and tailor the design by changing some of the knobs on the spider charts to go optimize at all those things. And that's what Forrest was talking about this morning with our ability to take our microarchitecture, our chiplets, and our packaging to dial in, more unique optimizations for the ranging workloads as they change. Large physical monolithic applications aren't going away. Just like the mainframe still exists, there's still some mainframes. And so we want to optimize to get the best performance per watt across that spectrum. We want to make those optimizations.
When you look at where we're going in terms of pure performance capability for AI, and it's been a big discussion today, and I'm sure it will be for the entire week. When you look at that workload and you look at training and inference, where do you think CPUs come into play, and how does AMD more strategically address the full continuum of the workloads across AI models with your full portfolio?
Well, I think, there's the one thing that, I heard this morning at least is when you saw that from Meta's description this morning of all the different spider charts they showed of different stages of pre, inference, decode, and they showed all these unique different optimizations. And I think that's where, the advanced architectures that we have that are in the works with our unique packaging and chip distributor mix and match come into play to cover all those, because it's not going to be one size fits all.
Right.
There are plenty of inference, jobs and applications that are going to run perfectly well on a CPU with AVX 512. There's going to be these trillion parameter training jobs that need to run on a what we call a flagship GPU, which is kind of the high end of the GPU range, and you're going to have everything in between. What's really going to be critical is the compatibility of the software across that spectrum. So for AMD, we're very focused on the CPU side of delivering core scaling with the right ingredients for AI, at the CPU level. And then on the Instinct line, we've got the flagship GPUs that we've talked about, the MI300 family that is coming out, that will be very optimized for some of those spider charts that Meta showed around training and large-scale inference, where the CPUs just aren't going to be a good fit. And so we're trying to optimize across that spectrum.
Everybody's talking about Meta's spider chart today.
I know. That was the best charts I've seen. It was great.
I'm going to have to get a picture of that for the TechArena. We're talking about performance, but I want to make sure that we cover other vectors of what you're delivering from a processor standpoint. And I'm just going to start with security. Security is something that is always ranked as a CIO's top priority. Beyond performance, security matters. And hardware root of security is really critical. I know that you have baked a tremendous amount of security features into the EPYC product line and take this very seriously. Can you just start with a review of what's in the processor today? What does it deliver in terms of core capabilities? And then we'll get into where you're going to go in the future.
Sure, I will take that. At the core of our SoC architecture, one of the key principles that we have to follow is ensuring the integrity of the very first instruction that executes on our CPUs. At the heart, we have our AMD security processor, which we have built and it's been across many of our portfolio products. That forks that root, and from there spans the chain of trust that builds all the way up to the runtime execution environment to start. And the critical part is to not just to say it is just the SoC that does all the work. It's the combination of the SoC, firmware that run on the SoCs, within the SoC, on top of the SoC, and the application infrastructure to ensure there is end-to-end CIA attributes that are secure along the way. Once you have the SoC in that form, you still need a platform to go with.
Right.
So fundamentally, we kind of need to have a secure platform to do any of these advanced operations, load a new AI model on it and make sure it is not tampered with, right? Nor somebody takes that IP away from that platform. How do we secure that, right? A platform level attestation to ensure the integrity and the authenticity of the platform is secure first, and then go off and say, okay, am I supposed to allow a particular application to run on this platform? Check, access control attributes come in, authorization comes into play. And once you check all of those buckets, then the advanced features that we have on our products for the high-end confidential compute type of environments. The other part that we also need to comprehend in the big picture of that scheme of things is not just adding security features, but making sure you have a high assurance bar on it. You have ample transparency capabilities built around it. As you might have heard in this morning's keynote, OCP announced the SAFE program.
Right.
We are piloting and collaborating with a bunch of our partners in the industry to say, as we build our firmware for our SoCs, along the life cycle of the development process, we do constant checks on the quality of the code. Because that's your opening point before you go into any more sophisticated attacks into the horizons. We ensure that the code is audited by a third party so that our customers feel comfortable that this is not just us building the code, but somebody else has looked at it, they have endorsed it along the development lifecycle of the product. And that endorsement becomes a key part in the overall platform orchestration, where the assurance has a certain score to say, somebody look at this device and they have looked at the entire platform. Now I can go and say, hey, this is a secure platform that he has been tampered with. Now I can unleash a workload on.
So, Prabhu, when you look at security, we know the bad actors are getting smarter and smarter every day. They're finding new ways to try to exploit organizations and get access to applications and data. AI is giving them some really fancy tools to make them even more sophisticated in this. When you look at that challenge, is there anything that the hardware industry and AMD in particular is aiming to do in the future to give organizations even more tools to protect themselves?
Absolutely. Back in the days, data at rest was a prime feature that one would go after. I need to have security in my storage devices. The data is at rest. Data is in motion. How do we protect it? How do we protect data in use? That's where all of our comprehensive compute capabilities come into play, ensuring whatever is in use is protected from bad actors.
When we look at a platform, there's something about balance and sustainability that's important. OCP has a huge initiative around compute sustainability, and I know that AMD takes energy efficiency and delivering sustainable platforms very seriously. Robert, what advancements have been made on the platform to drive increased energy efficiency, and how do you look at that challenge when you're working with your architects on what are the core capabilities to think about? Is it driving better performance per watt? Is it really about getting to idle faster through pure performance? How do you ensure that you're delivering the most sustainable product to the customer?
Yeah, so for us, it really starts at the microarchitecture. If you think about our core design, and we're trying to make a highly efficient and performant core. And and Forrest talked about it this morning about how if you look at our core size versus the competition, it's significantly delta, right, between the two. And that's because we're focused on providing, core scaling where everybody benefits from core scaling. And we do believe in accelerators in heterogeneous compute. We have a whole GPU lineup, but we don't believe that you should inundate your core with things that aren't used a lot, because that just adds transistors, thinking power, and they don't tend to have the biggest bang for the buck when they're buried deep inside the core. They're better off with a performance per watt as a truly optimized domain-specific architecture. It's always going to be the best performance per watt. So we start with a highly efficient core, give you a lot of them, keep them lean and mean, give you a great balanced SoC of high memory bandwidth, high I/O, and deliver platform-level features to guarantee quality of service between all those cores so that they don't interfere with one another. So we're really focused on driving the performance per watt, and as Forrest talked about with some of the advanced packaging technologies, our ability to drive beyond the radical limit of silicon by using chiplets If you saw his charts and you saw kind of the reticle limit of a monolithic die versus how much silicon we can put in package using chiplets, it's an order of magnitude more silicon that we can put in. And the more silicon that we put in that is collaborating to deliver performance per watt, we're saving a lot of energy efficiency on transferring data back and forth between chips and so forth. And so that's really the best lever we have today to drive energy efficiency is through deeper levels of integration, core scaling, and breaking reticle limit on silicon design. So that ultimately, yes, we are driving much higher performance, but we're moving the performance per watt knob up significantly versus if all we delivered was just by a monolithic die at a reticle limit, the performance per watt improvement would be very, very small. By breaking free of that reticle limit and advancing Moore's law, we can really move the needle on performance per watt, which is the best way to drive data center efficiency and consolidation. I mean, as an industry, if you turn the clock back in time and look at the big picture, we've been consolidating from mainframe for the last 50 years, right? From these big monolithic machines, and we've been consolidating towards these, highly integrated devices with the right functions and features. And that is the best way to drive the performance efficiency.
Thank you guys so much for being with me today. I know it's a busy conference and you took out some time to be on the TechArena. One final question for you both. Where can folks engage to learn more about the EPYC product portfolio and engage with your teams to talk about their own needs and potentially deploying some EPYC servers in their data centers?
We have our AMD booth on the expo floor. Come drop us a contact card. We get hold of you, walk you through what we need to do to get on board. Run on EPYC.
Yeah, and to add on that, I think one of the big principles of AMD's culture that Lisa has really instilled in the company culture is we are customer inspired. We listen to our customers, we engage our customers, we try and figure out what problems they're trying to solve. We don't have all the answers, nor do we understand all the problems. So the best thing we can do is engage the at-scale customers and understand their at-scale problems. And I can tell you from my experience, the at-scale problems are different than the enterprise problem.
Right.
And we have to listen to that whole range of customers and optimize our products, our security, and our solutions based on the direction that we're getting from our customers, and then come up with innovative solutions. And that's really the heritage of AMD is a very advanced architecture and engineering company to go solve the world's biggest problems. And you can only do that by listening.
Well, thanks, guys, for being on today. That was really inspirational. Thanks for the time.
Thank you.
Thanks for joining the TechArena. Subscribe and engage at our website, thetecharena.net. All content is copyright by the TechArena.